Okay, so this is worksheet 4. I'm just doing problem 9 and 10. This is a pretty typical question on the new style exam. So a student is asked to determine the molarity of calcium plus 2 ions in 50, so we're trying to find molarity in 50 milliliters, and it's molarity of plus 2, in 50 milliliters of solution. By adding a 10% excess of sodium carbonate to precipitate out calcium carbonate. The precipitate was filtered, washed, dried, and weighed to give 1.2 grams of calcium carbonate solid. So when you have something like this, it's always very helpful to write a balanced equation. So I know that I am precipitating out calcium carbonate, so that's a product. I know that I am adding sodium carbonate. Doesn't say what form. It could be just solid, or it could be a solution. And I'm trying to figure out the concentration of some solution that has calcium ions in it. Okay? And what I know is I have 50 milliliters of this, and I get 1.20 grams of this. And I know that this is being added in excess. And I am trying to find the molarity of this. Okay. So, in order to get molarity is going to be the moles over the liters. So I have the volume. What I have to do is find the moles. Okay. So, and from the calcium standpoint, this equation is balanced. So, if I have 1.20 grams of calcium carbonate, if you find the molar mass of calcium carbonate, you'll find that it's 100 grams. And that's why this substance is used a lot on multiple choice questions, because it's a nice round number. 100 grams of that is 1 mole of calcium carbonate. And I'm just going to abbreviate because I'm not having to show my work. And 1 mole of calcium carbonate is 1 mole of calcium ions. Okay. So 1.2 grams divided by 100, all I have to do is move this decimal point 2 places, and I get 0.012 moles. But that 0.012 moles has to be divided by, if I had 500 milliliters, that would be a half a liter, right? 0.5 liters. But I have 50 milliliters, so it's 0.05 liters. Now, in order to solve this, I'm going to simplify by getting rid of the zeros for both, and I'm left with 0.12 divided by 0.5. Now, the way I think about this, and you might do it differently, is I could take that 0.12, and the 0.5 is really a half, right? 0.5 is a half. And if I am dividing by a half, that is the same thing as multiplying times. I invert what's here, 2 over 1, right? Which gives me 0.24 molar. So my answer is going to be, it should say C, but it's the third choice, 0.24 molar. Okay, so let me erase some of this so we can talk about the next part. So the second part says, if the actual value of the molarity is 10% higher than that reported by the student, which procedural error could be responsible? All right, so what they're saying is this is higher than it should have, than what I got. Okay, 10% higher, which means my value I got was too low. And because the only product that I have here, that I have a mass of, that I'm using to figure out how much of this I have, is my calcium carbonate. Okay, so I have, what that tells me is the mass of the calcium carbonate is too low. It gives me a value here that's lower than what it actually is. So I have all these things, and I have to look at which of these is going to make my value of calcium carbonate too low. So let's take them in turn. A says a student used a 20% excess of sodium carbonate rather than the suggested 10% excess. as long as there's excess, it shouldn't matter whether it's 20% or 10%. And in fact, if it's 20% instead of 10%, it's just going to cause that reaction to go further to completion. So this is not going to cause me to make less calcium carbonate. Choice B says the student did not subtract the weight of the filter paper from that of the filter paper plus precipitate. So if I have filter paper plus precipitate minus filter paper, this is, and I don't subtract this is going to make my answer bigger, right? So it can't be B. All right, the second choice was the precipitate was not washed sufficiently. So what that means is when we have a precipitate, and you'll see this in lab, that we collect in a funnel, right? We drip the liquid out. We always have to wash it. We spray it with water, distilled water, to clean that really well, because if there's any residual ions in there, we want them to go through so they don't cause the mass to be off, okay? So if we did not wash the precipitate thoroughly, then we're going to have extra mass in here. This again is going to make the resulting mass too high, so it can't be C. So let's look at D and see if it makes sense. D says all of the precipitate was not transferred from the beaker to the flask. So I had a beaker with this calcium carbonate was formed, precipitates out at the bottom. And what this says is when I poured it into my filter paper, I didn't get all the solid out. Now that would result in having a lower mass than what I should have had. So that's going to be the correct answer. The answer is going to be D. All right, I'm going to stop right here.